presentation. This is Tuesday the 11th. And the preview activity, we kind of went through that. The velocity equation, which is kind of not a, probably a little bit convoluted example here. Somebody's velocity of walking is not going to follow a cubic equation. Go slow at first and then pick up and then kind of hold here. But anyway, the distance they traveled is represented by the area underneath the curve. And they talked about these three approaches, and one was what's going on with these areas. And each of these rectangles is trying to estimate the area for that first interval of 1/2 hour. The second interval of 1/2 hour, notice that this one's low, and this one's low, and this one's low, and this one's low. So this is going to be an underestimate, but it's working off the height. The rectangle's height is on the left side of the rectangle, sits on the curve. The left side of this rectangle sits on the curve. The left side of this rectangle sits on the curve, and the left height is determined by where the left side is on the curve. As opposed to on this one, they're all on the right side. And then here, they're all in the middle of the interval. And you can see that the sum of area 1, 2, 3, and 4 would be an underestimate. The sum of the areas B1, B2, B3, and B4 would be an overestimate. And the midpoint ones, there's some under and some under and some over, so this might be pretty close. This has a little bit that it's missing, but it's got some extra here, so a little missing, but a little extra, and pretty close there. So the midpoint one would be the closest estimation for the area. Okay, so hopefully that'll give you enough information to be able to go through and work the preview activity. Then from there in class, I went to a little something different. There I said, okay, there's a story about a elementary kid from a long time ago who was kind of being a pain in class, and so the teacher said, I'm going to keep him busy, and said, add up the numbers from 1 to 100. And the teacher was thinking that would keep the kid busy. Well, it turned out it didn't keep the kid very busy. This kind of an exceptional math student figured out the answer in a few minutes. Said, I got the answer, teacher, and the teacher didn't believe him. And it turned out that he was correct in what he didn't go. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, and work it out. We believe, you never know what's going on inside somebody's head, but we believe that the kid did 100 plus 99 plus 98, wrote the sequence backwards, kind of, if you visualize it, this kind of looks like a triangle, height of 1, then 2, then 3, and then 4, and 5, and 6. So you get kind of a triangular shape. And if this may be what he was doing in his head, he said, well, I'll just do this triangular shape backwards on top of it, flip it over. So I'd have a height here of 101, and 2 plus 99 is 101, and these would all be 101. So, and he had 100 numbers that are 101, 100 pairs of numbers, all summing to 101. So he said 101 times 100, but that would be adding up the numbers twice, and so I'll just cut that in half, which is 50-50. Now you're saying, what the heck's that got to do with what we're doing? Well, there's another way to write this. And in class I said, does anybody recognize this symbol, this letter? And some people said that it's a Greek S or sigma. And I said, does anybody recognize this symbol? And they said that's a Greek capital P. This is capital S in Greek. There's small s's, sigmas, but that's capital. And that's a capital. This is a capital S. And this is a capital P. And this is used for adding up stuff. Strange that sum is what you do when you add stuff up, and that's an S. And this is a P, which is when you have to multiply a bunch of things. So, in mathematics, we use this symbol, and we have an index. That's an integer. So there's two reasons to call it I, index and integer. Integer is like whole numbers that could be zero, positive whole numbers, or negative whole numbers. So, and they start someplace, like they might start at 1 and go to 4, or they might start at 1 and go to 100, like they did in this case. And if I put I here, well, I will be 1, and so this would be 1, sum, add, and then make I go to the next integer, which would be 2. So add to 1, the 2, and then we make I be 3, then 4, and 5, and 6, and stop at 100. And so this says, find the sum of all these numbers. Now, if I did it with this symbol, this would mean to go 1 times 2 times 3 times 4, all the way up 2 times 100. Not something I want to do, so we're not going to worry about the pi. We're going to talk about the sum ones. And so then I said, let's practice a little bit. What would this mean? I going from 1 to 5 to I. What would that be? And so if I put 1 in here, 2 times 1 is 2, plus, because I'm doing sums, and then I make I go to the next integer up, which would be 2. 2 times 2 is 4. Then I goes to the next one. 3 times 2 is 6. Then it goes to the next one. 4. 2 times 4 is 8. And then the next one, 5, which is the last one I'm going to do. 2 times 5 is 10. And this would be saying add those numbers up. And its sum would be, let's see, 10, 20, 30. Okay? So that's the idea of the sigma notation. And it could start at 1 and go to 5, or it could start at 0 and go to 4, and there'd be 5 different numbers or whatever. Okay. So then going back to the preview activity, I said, let's write a summation notation for the sum of area 1, 2, 3, and 4. So, since we're doing 4 areas, I could make I go from 1 to 4, or I could make I go from 0 to 3, 0, 1, 2, 3, that's 4 numbers, okay? And then, the area A1, its width is a half a unit. This is 1, so that's a half unit. The width of the second one's a half, the width of the third one is a half, and the width of the fourth one's half. They're all 1/2. So each one is going to be half times the height, and the height is determined by this velocity equation. And we need to find out the velocity at, well, first we want to find it at 0. Then we want to find it at 1/2. Then we want to find it at 1. But since I'm working in halves, I'm going to make these all halves. So 0 halves, 1/2, 2 halves, and 3 halves. So I'm finding the height here, 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 and here on the left side of each one of these. Well, if I is 1 to 4, and we notice the numerators are 0, 1, 2, and 3, I could do I minus 1 over 2. So when I is 1, 1 minus 1 is 0 over 2, which would be, and then find V of that number, which would give me this height, times 1/2, and that would be the area of the first rectangle. And when I is 2, 2 minus 1 is 1, 1/2. V of 1/2 would be this height, and this 1/2 would be that width, so that would give me the second rectangle, A2. And when I is 3, 3 minus 1 is 2, 2 over 2 is 1, and that, if I plug that into V, this V, I get this height, and that area of number 3 would be that height times 1/2 wide, and then I'd add it to area 4, which I should get if I put in 4. 4 minus 1 is 3. 3 over 2 is here. The velocity there is this length times 1/2, and that would give me area 4. Now, if I'd happened to make I go from 0 to 3, this would have been a little bit simpler. I could have said V at I over 2, because this looks like 0 over 2, then 1 over 2, then 2 over 2, and then 3 over 2. Figure out the heights at each of those places, V of those. Take that answer times each one of those times 1/2, and add them up, and that would be the sum of area 1, 2, 3, and 4. And again, either one of these would give me an underestimate for the area under the graph. So then in class I said, let's do it for these. So now I'm figuring out the height at 1/2, at 2 halves, at the height at 3 halves, and this last rectangle has the height at 4 halves. And when you write something like this, it kind of helps you see that I could be 1, 2, 3, 4. So I could start at 1 and end at 4. The width of each one of these is 1/2, and the height is the velocity equation with 1/2 plugged in, and then 2 halves plugged in, and then 3 halves plugged in, and 4 halves, or I over 2. This one is a little bit trickier, where we're doing the midpoint. So we want to find the height at 1/4, then the height at 3/4, not 0, but 1/4, not 1/2, but 2/4 in the middle, not 3/4, but 4/4, but 5/4, and 7/4. So this is not 1, 2, 3, 4. It's 1, 3, 5, 7. So let's see if we can write summation for that. I'll let I equal 1 to 4. The width of each one of these is still 1/2. And the height is determined by the velocity equation evaluated at 1/4 for the first one, 3/4 for the second, 5/4 and 7/4. How do I get that to happen when I is 1, 2, 3, and 4? Well, if I do 2I, I would get 2, 4, 6, 8. Each one of these is 1 less than 2, 4, 6, 8. So if I go 2i minus 1 over 4, that would give me 1 times 2. 1 times 2 is 2, minus 1 is 1 fourth. Find the height there. Then if I put 2, 2 times 2 is 4, minus 1, 3 fourths. Find the height, v of 3 fourths, that's this height, times that width, 1/2, and that would give me the area C2. And then when I is 3, 6 minus 1 is 5 fourths, so I'd be finding the height, v of 5 fourths, taking it times 1/2, and that would be that, and I would add all those up. So there's one possible way of writing this. There are others. Okay? So that's kind of a clue on how we're going to tie this sigma notation, the summation notation, into finding areas. Now, kind of the next thing I did in class was I said, what if, where did I make this? Here it is. What if we decided to take this first one and do it not 4 rectangles on the left side, but what if we made it 8 rectangles at 1/4, then go up at the 1/4, another quarter wide, and then go up there, and then go up to there, and then on the left side of the next one, and then down, and the left side of the next one, and down, and then the left side of the next one, and down, and the left side of that next one, and down. So I could have I equal 1 to, since now I'm doing it 8 different ones, I'm going to have to go from I equal 1 to 8, or potentially I going from 0 to 7, because 0 to 7 is 8 different numbers. Or I could do some other combinations. But these two turn out to be probably the two simpler ones. Now, like I did before, I kind of made a common denominator and labeled where I'm trying to do all these at. Let's do that here. So I'm trying to do it at 0, at 1/4, and here is 1/2, which is 2 fourths. So if I do it all in fourths, the next one is 3 fourths, and 1 is 4 fourths, 5 fourths, 6 fourths, and 7 fourths, and that's the left side of each one of these. Left side of this one, left side of that one, left side of that one, that one, that one, that one, that one, and this small rectangle down there. Okay, so I can see 0, 1, 2, 3, 4, 5, 6, 7. Well, that's kind of what this is. So this would be, once again, I got to find the area of this rectangle, I have to take its width, which is 1/4, times its height, which is determined by the v equation, the height at 0 fourths, or I over 4. And then when I is 1, we'd be finding the height at 1/4 times the width of 1/4 would be the area of that one. That would be my second one. Then my third one would be 0, 1, 2, 2 over 4, or 1/2. That height times a width of 1/4, and that would be the area of the third one. And so this would be probably a better approximation than the one with just 4 rectangles. Now, if I had chosen to go 1 through 8, the width of each one would still be 1/4, 1/4, 1/4, 1/4, etc. The height would then be, I have to get 0 fourths, 1 fourth, 2, 3 fourths. Well, each one of these is 1 less than what I is, so I could just say I minus 1 over 4. So when I is 1, 1 minus 1 is 0 fourths is where we want to do our first one. When I is 2, 2 minus 1 is 1 fourth. That's where we want to do the second one. Find the height at that place times the width and add all those different areas up. And finally, the last thing I did in class is said, well, instead of doing 4 rectangles or 8 rectangles, what if we wanted to do n number of rectangles? Keep increasing these numbers. So if I did it with n of them, then I would have to go from 1 to n, or possibly I going from 0 to n minus 1, just like we did here, either 1 to 8 or 0 to 7. And then I would be figuring the height. Well, let's see, I'd have to do the width. Well, the width is going to be, if I'm going to split it, if I split it into 4 of them, I took my total width, 2, and divided by 4, and I got each one a half wide. And so when we were doing it before with these, total width was 2, divided by 4 makes each one of these 1/2 wide. That's where I got this. 2 minus 0, the width of the interval, the width of where we're finding the area, divided by, we're doing 4 places, so that makes 1/2. So now when we're doing, and when we did it with 8, it's 2 minus 0 over 8, which was 1 fourth, and that was the width of our interval. So if we're doing n of them, it would be 2 minus 0, or 2, divided by n, and that'll be the width of each one of these. Sometimes that's called delta x. Then if I'm doing left-sided ones like we were before, then I got to take the velocity at the left side. So the left side is going to be 0, excuse me, 0 is going to be the first one. Let's just kind of write the ones that we would have. The first one would be 0. Second one would be 1 of the widths, 2 over n. 1, 2 over n. 0 of the 2 over n widths, plus 1 of the widths, plus 2, the second width, go 1, 2 widths over, 2 of the, each one is 2 over n. Then the next one would be 3 of the widths, 2 over n, etc. So it would be v, if I did this one, it'd be 2 minus 0, which is just 2 over n, v of I times 2 over n. And that would get us all these places. Okay? If I did it up here, it would be I minus 1 times 2 over n. And that's kind of where I ended today, the Tuesday, the 11th of January. And I will continue with this tomorrow.